we saw how the alignment scores are calculated. Okay, so they are dependent on some hidden states of the encoder blocks and some hidden states of the decoder blocks. Okay, now there are two types of ways by which these alignment scores are calculated. One is Bahdanau attention, another one is Luong attention. First, we will be talking about Bahdanau attention, how the alignment scores are calculated. What happens is we try to guess this function, right? Here Hj is the hidden state of the encoder block that we are focusing on currently. Si minus is the hidden state of the previous time step of the decoder block. So what we do is we concatenate both these vectors, make it into a single input, pass it through a feed forward neural network. Okay, we can decide the number of hidden states here, then pass it through a single neuron, then pass it through a softmax layer, then finally we obtain the alignment scores. So let's say here the dimension is 4 of all hidden states. Okay, we can see this H4 will be passed as S0, right? So the dimensions would be same. This is the reason why we took all these dimensions as 4. So H1, H2, H3, H4 and S0. Let's say we are checking for time step 1. All these will have dimension 4. We are trying to calculate C1, which will look like this. So these are the alignment scores: alpha 11, alpha 12, alpha 13, alpha 14. These are the alignment scores that we wish to calculate. What we now do is we concatenate S0 along with H1, H2, H3, H4. So S0 will be expressed as S01, S02, S03, S04 because it's a 4-dimensional vector. Okay. Similarly, H1 would look like this. H2 will look like this. So H3 and H4 can be written in similar way. So all the hidden states will be expressed as vectors of dimension 4 and then we concatenate them. Okay. We want to get alpha 1, alpha 12, alpha 11, alpha 12, alpha 13, alpha 14 like parallelly. Okay. We want to execute this as a batch operation. Like together we want to get all these 4 values, so parallel processing will happen. So we take all these vectors in the same matrix. Okay, we concatenate them together. So this is the first row. We can also pass them in the order of rows, right? So first we will pass the first row, then the second one. But here we want to calculate them in the form of batch operation. Okay, so parallelly we want to compute these values. So we want all 4 values together. This is how the concatenated vector of all these above vectors will look like. Okay, so it will be a large 4 cross 8 matrix. So we have our input matrix of dimension 4 cross 8. Let's say the number of hidden states in number of neurons in our hidden layer is equal to 5. So we take an 8 cross 5 weight matrix and a bias of dimensions 4 cross 5. Okay, so when we do these operations into 8 cross 5 will give a 4 into 5 matrix. Then bias also have the same dimensions. So finally, after getting these values, we pass it through the activation layer. Let that be tan h. Okay, so we get a 4 cross 5 matrix as output. Now these neurons are connected with a single neuron with a 5 cross 1 matrix. Okay, so when this is these new weights are multiplied with this, let them be WO, you obtain a 4 cross 1 matrix. So your 4 cross 1 will be passed through a softmax 4 cross 1 matrix will be passed through a softmax layer. So you will get your alpha 1 1, alpha 1 2, alpha 1 3 and alpha 1 4. So all the input values of the attention inputs will be calculated. All the alignment scores will be calculated.